Alright guys, your third station is multi-step equations that involve variables on both sides, or when I have an x or whatever letter I'm using to represent a number on the left and the right side of the equation. And this is new. We haven't done something in class that's similar to this. It's not like the other two stations where we really had already done distributive property and combining like terms with expressions, and we were just applying it to equations. This is new. So you have the checklist there. In the order that we have to go, we need to first move all of our variables to one side. We then need to two-step equation, undo addition or subtraction, and then undo multiplication or division. I'm going to start same way, draw a line through the middle to show that I'm keeping it balanced. And when I talk about moving a variable from one side to the other, I'm always just going to be adding or subtracting it. In this case, I can move either. I'm going to choose to move the 4b over from the left side to the right side. And the only reason that I'm choosing to do it that way and not the other way is because I'm looking at the numbers, the coefficients that are attached to b, and I see that, well, if I subtract 4 from 7, I'll still have a positive number. But if I subtract 7 from 4, then I've got a negative number, and I just added an extra step sort of for no reason. So what I'm going to do is write in minus 4b on the left and on the right. This is the same as any other additive inverse, like 3 minus 3, 3 plus negative 3. 4b minus 4b is 0. It's the same idea as when we add or subtract anything to remove the constant. Now we're just moving the variable. 7b minus 4b is 3b. I still have this plus 7 on the right, and I still have this minus 8 on the left. Now don't get hung up on, is that a subtract 8 or a negative 8? It's really the same thing. The way I read this now, before would have been 4b minus 8. The way I correctly read this now is negative 8 is equal to 3b plus 7. And now I just took care of moving the variables to one side. Now I am right back at a two-step equation. And I'm going to use the what I see, what I will do strategy again. And if I'm looking at the math that I see that b was multiplied by 3. And so I know when I solve it, I'll need to divide by 3. That is the opposite of multiplying by 3. I also see that we added 7. And so when I solve this equation, I will subtract 7. And just like we've done in every other two-step equation, we know that we start with addition or subtraction and then finish with multiplication or division. So I know this equation, the way it's written, looks weird as compared to what you're used to seeing, which is why I did it this way on purpose. So you're used to seeing the variable on the left-hand side. You can solve it the same way when the variable is on the right-hand side. Do not let that throw you off. So what I need to do is still isolate the variable b. It's just over here. So I want to start by subtracting 7 from each side. Negative 8 minus 7 is negative 15. And I'm left with 3b. And that's it, because this positive 7 take away 7 is 0. So I just took care of addition or subtraction. From my pre-plan, I noticed that I'd be dividing by 3, so I'm going to do that. And 3 divided by 3 is 1b, or just b. And negative 15 divided by 3 is negative 5. So now you should put together the cutout strips that are at your desk that are the step-by-step solution to a problem involving variables on both sides. Make sure you also include the reasoning. Those are on the other strips of paper. And then you should complete the 2 problems that are on your capture sheet.